Calcium is ubiquitous. In the analysis of pigments, we are going to find calcium most of the time because basically calcium is used in the preparation layer of a painting. Could be a white ground layer made of gypsum, so calcium sulfate, like in Italian Renaissance, or it could be made with calcium carbonate, like in paintings from North Europe. When we do the XRF analysis of the pigments, they are on top of the ground preparation, but definitely some of the calcium, the signal from the calcium of the ground preparation, will contribute to the final analysis. Also, calcium, in particular calcium carbonate, will be used as a filler in most of the pigments, can be added. So we're gonna find some calcium because of the filler. Calcium is not useful for the identification of the pigments because again it can be due to the ground and to the filler. In this lesson I will just discuss some little bit of application. Calcium is here 20. Here we have the table of the XRF peaks. So calcium over here, it has a kappa alpha line at 3.7 and a K beta at 4. They are far apart, 0.3 keV difference. They are far apart, and indeed we will see the peak separated. To introduce calcium, I used the pigment checker. I wanted to check, first of all, the acrylic binder that is over here. This is a piece of the cardboard where I paint the colors just with the binder on top of it, without any pigment. We see, so it's the black spectrum, there it is, so we see the peak of calcium. So 3.7, and this one is at 4 keV, is the K beta line over here. We have enough counts, we are in the order of 60,000, the signal is strong. I'm using the no filter setup. Then I tested chalk. This one over here is on top in the pigment check. So we have over here chalk. Chalk is calcium carbonate, and indeed we see a lot of calcium over here. So the peak is much stronger. Then to see pigment that contains calcium, I tested bone black. So the pigment checker is over here, bone black, and there it is, bone black. So bone black is made of charred bones. What we have is calcium phosphate from the bones. And indeed the blue one, the bone black, the spectrum is this one. We see a little bit more calcium compared to the ground layer, because remember, in the acrylic binder we tested and we found the black one, this amount of calcium. Bone black has a bit more calcium on it. Of course, if there is a chalk, we have much more calcium. Let's see another example. In order to make the paper feeling more smooth and more adapt for the writing, paper manufacturers added calcium carbonate. I tested 3 samples of paper from different centuries. We have, this one is from the 16th century. Actually, it has a date on it specifically, so it's this one over here, 1527. So for this object is the black one, so 16th century, we get this spectrum. So we see the peak of calcium over here with counts 30,000. Then we move forward in time and we go into the 18th century. So we have this other item from the 18th century. Actually, there is the date 1799 is this object over here. And the measurement of this object, so the red one, showed that the amount of calcium is much less. Then I tested this object also, this one 19th century. Actually there is the date because it's a document, a notary document, so with a specific date, 1898 over here. So 1898, 19th century is the blue. So in this paper we find even much less calcium in it. And then I tested just a standard copy paper, the one we use every day in office, and in this case the amount of calcium is much more, the green one. These are just examples of different kind of papers. Paper were treated, there is all in industry about the technology of paper manufacturing, but the idea with this simple collection of spectra is that we can quantify the amount of calcium used in the manufacturing of these three papers across ages.